Today we'll be looking at states of matter. It's a basic topic that you would have gotten from like third form, fourth form. Alright? Nonetheless, sometimes it can come a little challenging in the exam. So you should still review it before the exam. Clear, Parkinson?
Yes,
Review it before the exam. Don't take anything for granted in the exam. Alright? So matter is anything that has volume and mass. Alright? And there are three states of matter, as you know. Solid, liquid, gas. So solid state, liquid state, and the gaseous state. The first basic thing, right, Mr. Harding? Good. So if you notice the stuff that we have been studying so far, either gas which have large volume, and they would all weigh something, so they actually have mass. Alright? And as we discussed, like metals, solid, mainly like you have some non-metals that are liquid, and we have like gases, oxygen, hydrogen, nitrogen, etc. Gaseous state. Alright? And we'll discuss them further. Particles. Alright? Particle. So it's four main ideas behind the particle theory of matter, right? One, all matter is composed of particles. Particles in constant motion. So even solid particles, even if it is a piece of metal, even the tile, the atoms are the particles that make it up, they are vibrating, so they are still in motion. They may not move as fast as how the oxygen and the nitrogen move in the air, but they are still moving, right? So particles are in constant motion. Some vibrate, some move slowly, some move rapidly like the gases. Particles are empty right? So in this room here, we have the oxygen, the nitrogen gas, we have water vapor, carbon dioxide gases moving. In between those gaseous particles, there are empty space. Particles have forces attraction between them. As we know, the forces of attraction between particles in the solid state, they are normally stronger. Alright, not necessarily stronger, but they tend, compounds that are solid tend to have a stronger forces of attraction between them. Right? While compounds that are gases tend to have minimal force of attraction between them. And then liquid would be in between. Alright? So this will overlap with biology. Right, so four main factors for the particle theory. So they are in constant motion, they have empty spaces between them, there are forces of attraction between them, right? And they are all composed of particles. All matter is composed of particles. So that's what we just talked about the theory and the evidence. Now, and this is one, diffusion. What is diffusion?
The diffusion is the movements of particles.
Yes?
From a region of high concentration to a region of low concentration, or in between the spaces of other.
Now just keep it at that. Keep it as that. Just keep it as simple and to the point in the exam, right? So it's the movement of particles from a region, high concentration, low concentration. Right? Example, a chemistry example with color that we can technically do in the lab is dissolving calcium permanganate crystal. This is our purple solid, right? Right? In water. So if we have a block of NO4 solid, and we should put it in a beaker with water, which is colorless. Purple. After a while, you'll see that the crystal is going to disappear. So it will gradually break off bit by bit until what we're going to do here, basically the water, purple liquid. Right, and this purple liquid is KMNO4 in solution. Okay? So the reason, the idea behind this is that even though the potassium permanganate crystal was one block of solid, it actually is made up of particles, because by the process of diffusion, whenever we put it inside of a water, it moves from the solid, which is at high concentration, and dissolve in the water to areas of low concentration until it is evenly distributed. Alright. So example 2, to support diffusion. Between ammonia gas, this is ammonia, right? So what we'll do here is that we have it's a tube, glass tube, but we don't have any bottom or any top, right? So what you're saying is that we're gonna have one container here. This is concentrated HCl. Over here we have concentrated ammonia. Right? So if we should dip like a piece of cotton, which is concentrated HCl, it's gonna give off gas, right? And this piece of cotton over here, so right? No. Between hydrogen chloride gas and ammonia, which one of those two gas is heavier?
Ammonia.
Heavier. Chlorine is 35, hydrogen is 1, so that's basically 36. Nitrogen is 14, hydrogen is 1, so this is 17. So this is like a mass of 17 grams per mole. This is 36 grams per mole. So you can see that ammonia gas is lighter, showing technically it should diffuse faster in the air. You following? So if the ammonia diffuses faster, it simply means that whenever they react, HCl gas plus NH3 gas is going to produce NH4Cl solid. This is ammonium chloride. Which is a solid. Following? So it simply means that whenever these two gases combine, it will form a solid.
White solid. Form a white solid.
White solid, good. Even more specific, white solid. So if the ammonia gas diffuse faster in the air, it would tend to form the white ring here.
Closer to
The hydrogen chloride gas. Good. So this is how they will set that in the exam, right? So just to show here that this is ammonium NH4Cl solid. So it's a white solid. And this is also a form of diffusion, example for diffusion, to indicate where the hydrogen chloride here will be moving from high concentration to a lower concentration. Same thing here in concentrated ammonia. High concentration of ammonia gas will move in the air as ammonia gas, but it will move faster than the hydrogen chloride gas.